Hello all, I am Dheeraj from CSCA section. Today I am gonna give video presentation on bridge rectifier BEEE caa-1 and our topic is bridge rectifier. And first of all we are gonna give the introduction of bridge rectifier. A bridge rectifier is a circuit built from four diodes arranged in a diamond bridge configuration. It also converts the positive and negative halves of an AC cycle into unidirectional DC output, a technique known as full wave rectification. And we can observe the diagram here for connectors. And we have the output characteristics regarding this ripple and flittering. The raw output is a series of humps called ripple. A smooth capacitor charges on each peak and discharges slowly between them, dramatically flattening the output into stable DC. Yeah, we can also seen as peak DC voltage 1.4 voltage. RMS output is also known as 0.9 into V slash AC RSM, and larger capacitors reduce ripple. And we are also describe this as filtered DC output and also raw rectified outputs. And we can observe the graph, how the graph goes up and downs. Yeah, and these are common applications of bridge rectifiers. Bridge rectifiers are found in virtually in every devices that plugs into the mains. Their reliability and simplicity make the universal building block in electronics. And we can use in power supplies, laptop chargers, desks, PSUs, and phone adapters, and using bridge rectification as their first stage. And we can also, here we need to special mention the heat management. Under heavy load, diodes despite significant power attach heat sinks or the use of the PCB copper or as thermal spreader to prevent thermal runaway. And yes, we are observing bridge rectifiers. The heat management is also a crucial role for controlling the heat. So we need to regulate the heat. First, rate PAV generously. Use diodes rated as greater than 2 into peak voltage for reliability. And also you should must and should you can check current ratings factors in a surge current during capacitor charge up. And you should must add a fuse always for protection for the mains output with an approximately voltage connector. And finally we conclude the takeaways. First, full wave efficiency. The bridge rectifier uses both half cycles of AC, maximizing DC output and minimizing ripple. And four diodes, one purpose. Clever pairing of diodes ensures current always flows in same direction through the load. And third point, universal building block. From phone chargers to industrial drives, bridge rectifiers remain indefensible in modern electronics. And we should also take care about circuits in bridge rectifiers. Please make ensure using fuses and switches for the right directions. And mainly please take care of our electric appliances while the voltage is up and downs. Make sure must and make sure add a fuse to the circuits. Check the circuits. And we can also must consider heat management. If you are using heavy loads, please consider these following steps. And also we can common applications also we can see this laptop chargers, desktops, and phone adapters, and all we are using bridge rectifiers in everywhere in everything. So bridge rectifiers is very important nowadays. Yeah, and This is my video presentation for bridge rectifiers in BEEE topic. Thanking you all.